not smoking, there will still be about the same total deaths, hopefully less, hopefully people are living longer. So what I'm saying is that the diagram that you have there, which shows, say, a quarter due to hypertension, immediately you have a cure for hypertension or something. Those people may have died, or at least the pie chart will show the total.
A lot of these interactions are rather messy, and fixing one of them might have some other effects. For example, since we don't die of infectious diseases, we get Alzheimer's because we get older. But well, let's fix that problem when we come to it. So I think in general, fixing these ones are not going to solve everything. It's still going to be a small part of the whole thing, but it's a sizable chunk of people.
Well, it's the point I was trying to vaguely make was second system effect. That basically you spend sort of 80% of your effort on number one, and then probably 20% on what's going to be number one once you those things.
But it's also this gets back to all the risk estimations. How easy is it to fix the risk? So we have been thinking a lot about global catastrophic risk, and the archetypal one is of course asteroid impact. And well, here we got a comparison of, this is for Americans, and it turns out that let's see, asteroid impact 1.5 kilometers or bigger is a yearly risk of 0.76 micromoles. But okay. We know roughly how we could do it. It would probably involve sending Bruce Willis to space, or maybe some more clever unmanned probe. So it would be pretty expensive, but given enough time we could do. Supervolcanoes, which I haven't got here, but I think they're actually a much more serious problem. They should be, I think, they're probably the train accident level. We don't know at all how to fix. We can't fix the Yellowstone caldera. So even if they were a significant problem, maybe we would be still better off getting the money to Spacewatch. Doing this in a rational way is actually a quite interesting decision theoretical problem. But if we look at this kind of estimate here, I think this one is demonstrating an important biggest problem. At age 80, you're suffering 80,000 micromoles of mortality risk every year. And that shows really that, well, aging, that's the prime problem, I think, and everybody's ignoring it because it's of course natural and the standard thing. Similarly, people care a lot about cancer. Cancer research gets about 10 times the funding you get to neuroscience research. But stroke and other brain conditions cost society 10 times as much.
Sorry, Anders. Yeah? How much of a confound do you think there is between the category 1 and categories 2 to 5? I mean, how many of the aging deaths are heart disease / cancer, stroke?
A lot of them. So you shouldn't see this as a breakdown that this is the risk for that 80-year person. So this is a lot of individual ones.
Right.
And that's I think also micromoles. They're a tool for thinking a little bit about comparing risks. They're usually kind of order of magnitude estimates, so one shouldn't take them too seriously. But they're very, very interesting to make this kind of ranking. Yes, insect stings, lightning, well, they're actually less of a problem than terrorism, assuming 100 they're dead in terrorism in the US every year, which haven't happened really. On the other hand, earthquakes, which we spend quite a lot of effort against, well, that's a smaller problem. And bioterrorism, so far, we have not seen at all. So the interesting thing is, we can already see that some of the rankings of our priorities here are pretty weird. If we look at the number of micromoles saved per $1 billion of effort, some of these ones probably should be reorganized. And that's going to be pretty tricky, but I think having a little bit better idea about this relative risk. This goes also for these kind of everyday risks. There was a bit of an uproar in British media when it turned out that David Nutt, he would probably be a very interesting speaker at one of our meetings. He's a pharmacologist from Bristol, and been looking both on enhancing drugs, but also drug policy. And he pointed out that ecstasy probably shouldn't be regarded as that dangerous. It should probably move down to a pretty low category, because it's about as dangerous as riding. Actually, it's about twice as dangerous as taking a riding trip, but it's on the same order. Of course, that was not what the government wanted to hear.
You mean riding a horse?
Yeah. And it's interesting to compare things, like for example, traveling by jet. Well, there is a certain risk of dying of accident, but actually the cosmic radiation is about equal in the risk. At least if you go on transatlantic flight and so on. Where you live actually matters too. Well, New York and Boston are not terribly nice, but coal mines are obviously much worse. And yes, smoking is pretty obviously terribly serious. But even a thing like taking a little canoe or a pumping trip, actually we should consider. And this demonstrates an interesting thing. Although we might want to pay a bit to get rid of risks, there are certain risks we're quite willing to take. It might even be rational to take a lot of these risks. Similarly, I think this one is pretty interesting. It turns out that eating 100 charcoal broiled steaks, that gives you a certain number of rather unhealthy chemicals increasing your cancer risk. But just 40 tablespoons of peanut butter, which I don't think sounds that appealing, but it's much less. And I could imagine at least an American eating that much over a week at least. So some of these everyday risks, it might actually be good to try to calculate them, put them onto this and see where should we be going. I'm not going to eat any peanut butter, but I might actually think that steaks are less dangerous here. I should try to get the cardiovascular risk from it. That's probably much higher. Okay, so this is the kind of risk we're surrounded with every day, and normally we don't think about them too much. We don't think about how dangerous the cars are, and we tend to overestimate the risk of terrorism. But there is, of course, the really interesting thing, and that's risk we almost have experience with, but not really. Because these other risks, we have a lot of data, we have the statistics, we can quibble a bit about the confounders. But there is a lot of accidents which we really dread, which haven't happened yet, and might never happen, and we might not even have much experience with them. So swine flu is a good example. We have reason to believe that could be a serious issue. And this, of course, ties into all these problems in probability theory. This is a rather famous issue, which to some people's surprise it's still not quite satisfactorily resolved yet. So what is the probability of a sunrise tomorrow? Well, we got a lot of data from the past. We have a lot of sunrises. But should we say, oh, the probability is 1? Or, well, Laplace, who suggested this problem, he had his rule of succession, and he ended up, well, since the Earth was created in 404 BC, and we have about 6,000 years, he actually got a probability, which is, of course, very close to 1. The problem is that in probability theory, the frequentists think that probability should be regarded as the number of times something happens when you do it in a large number, an infinite number of times. The problem is, this is not necessarily applicable in all situations. And it's very problematic, of course, when thinking about risks. After all, if we can only have one Cuba crisis in history, maybe in the many worlds theory of quantum mechanics, you could, in theory, measure across the set of all possible worlds how many had a nuclear war. The downside is, of course, that doesn't seem to be possible from any physical perspective. So the kind of opposing camp in probability theory are the Bayesians, who say that, well, probability, that's a measure of belief, a rational belief. You're not allowed to just move it around as you feel like. You're actually forced to use certain rules if you want to pretend to be rational. But when you start, when you don't know anything, then you're going to have a prior level of belief, which is not going to be based on any mathematics, it's just going to be based on your general world knowledge. This is then going to be updated by your experience. So if you have a sunrise every day, you're going to increase the probabilities, and the rational thing to do is you're going to get a probability that approaches 1. Of course, Laplace kind of had the last laugh, because a lot of people have criticized his original paper without reading it, and he actually points out, of course, that once you understand a bit of astronomy and physics, you're going to know that the probability of a sunrise is essentially 1, because you have extra information about the nature of the system. But quite often we don't have that. The Cuba crisis, we can analyze what was going on there. We might even try to use that to predict what would happen in a similar crisis. But we don't have a really general theory about nuclear crisis. In the case of certain other disasters, we have actually a theory we can make pretty good predictions. So let's see here. So what I'm going to, I don't know how much probability theory you can stand on a Saturday. So just tell